You here on behalf of myself and our faculty director, Chris Berry, who's unfortunately can't join us. He has a very difficult teaching assignment in Barcelona, so he's away. He is, absolutely. But that gives me the sincere pleasure to welcome back Jordan T. Kemp to the Institute. Jordan is currently a postdoctoral fellow at the Santa Fe Institute. His research studies multiscale growth in urban systems, applying methods from biophysics and population ecology to uncover patterns that standard aggregate measures obscure. And by treating growth as an adaptive process across scales of organization, his work develops new tools for understanding how economic and social dynamics emerge from heterogeneous local interactions. Now, we're going to hear a lot more about that, I think, in a little bit, but I'm very excited to hear his work. Jordan received his PhD in physics from the University of Chicago, where he studied adaptive growth models in the Urban Science Lab and was a research fellow here at the Mansfield Institute. So, and previously was at the Institute for New Economic Thinking at the University of Oxford, focusing on complexity economics. So again, it's my sincere pleasure to welcome Jordan back. Thank you so much.
Yeah, thank you, Brian, for that great introduction. I'm really excited to be here because I spent 3 or 4 years attending these talks pretty regularly. So it's my pleasure to be able to give back to the community and show you guys some of the cool stuff that I've been working on. So this work started a little bit while I was still here. It's some work building on the previous director of Venezuela, Luis Betancourt's work. And just 2 disclaimers before I begin. This talk is going to be purely descriptive, so there's not a lot of modeling, there's not a lot of, I'm not trying to really prove anything necessarily to you in this talk, just to demonstrate this new analysis method, and hopefully we can together find ways that this could be relevant for you. The second is that the method falls directly out of the math of aggregating dynamics and growth, and so in that sense, there aren't any assumptions underlying the data that we're using. This is just applied directly to the data. And with that all said, please feel free to interrupt and ask questions throughout the talk. I really appreciate, especially since I'm introducing some new concepts, I think it's really important to make sure that you guys come along. So, raise your hand at any point. And so to get started, so we're going to be in this talk thinking about change in cities broadly and Chicago particularly. And when we think about the history of change in Chicago over the last 30 years or so, 40 years, the aggregate narrative has been one of stagnation. The population hasn't grown too much. There might have been economic growth, but depending on the news outlet you see, Chicago mayor, the situation is quite tenuous. But what I want to start with us thinking is that narrative is one that is emergent from local experiences. And so to get the ball rolling on that type of thought, I want to ask you guys, how is your Chicago changing in your neighborhood and the places that you frequent? So I have some examples throughout the city. So there's this industrial corridor in the Park on Ashland Ave that has undergone what we would consider divestment as industrialization has receded from the American economy. We see this type of scene throughout the city where formerly pretty robust, beautiful buildings have been torn down. But that narrative diverges from one that we see in other places in the city, like this neighborhood in Old Town that has undergone some doubling down on the capital, turning over housing stock from what is apparently middle income to upper income homes. Similarly, if you look at Pilsen in the Lower West Side as well as in Woodlawn, we see that there's some pretty active investment in both affordable housing in this complex that's going up on Ashland and 20 for Cermak, and as well as these homes on, I believe that's Dorchester Ave. But this is to say that this is one example of change. This is change in capital investments, but there's many other that we could also explore, such as in population, and these are ones that we can observe directly in data, but also legislative through zoning, the downstream effects of those on density, the spillovers on income, and wealth, and so on. And then these also have some externalities on, of course, service load, congestion, and so on. And so really understanding how not only this change could be, these modes of change really relate to each other, but how that change could aggregate from these micro street level examples to the aggregate narratives you might hear in the news, for example, is the heart of the work. But before we even start to answer that question, we need to get some definitions down, particularly change at what scale. And this is really a problem of scoping the question. And second, how do we ask this question and then answer that question in a way such that the results are coherent between scales, so that the answer that we get for the microscopic change can be explanatory of that macroscopic change we're trying to reconcile. And so just to get really concrete with what I mean by scale, so throughout this talk, I'll be discussing the ACS, American Community Survey data set, in which any countrywide demographic data is broken down into several levels of organization. The lowest would be block groups. And so we can imagine that the block group, the data at the block group level as this representative of that micro level of the city. And so I'll be coming back to this diagram a lot throughout this talk, but the essential idea is that each of these hexagons represents a block group with representative population and average income. And as we aggregate, we have data at the track level where we start to get some idea of what a neighborhood is. Maybe in the analysis, we take for granted that this spatial unit has some kind of local homogeneity that we can rely on to be representative.
Sorry to interrupt.
Yeah.
Where is the source of the data for the block groups? Is it purely census?
Yes. So this will be. I'll get to this later in the talk, but yeah, it's ACS census data from 2014 to 2019.
Got it. Thank you.
Yeah. And then, of course, this is Chicago-specific community areas where we start to see the importance of institutions and political organizations. And so as we do this analysis across scale, it's not literally just grouping data, but it's also trying to capture some of these scale-dependent effects as well. With the important point that there is the coherence given through the data aggregation process. Okay. And so to redefine the challenge in that light, it's really one of, as we coarse grain, and that's a term that comes directly from physics and ecology, how do we preserve these local patterns? And this is not a new question. This has been asked a lot throughout the literature that I'm getting quite familiar with myself. As somebody coming from outside of the urban studies literature, I'm still working through a lot of these papers. But there's been a lot of prior efforts to really understand how do we study the city as a multi-level system. But what we see in the literature is one of two treatments. Either in order to maintain analytical tractability, we collapse that heterogeneity, or we take static aggregates because dynamics are really complicated in part to analytically model. Or we have recursivity in a conceptual sense without some kind of explicit treatment of how to go between scales. And what we try to do in this work is find the right type of recursive description that allows us to both measure dynamics that are explicitly multi-level. And to our benefit, this has been largely what population ecologists have sought to do since Darwin, really. And so what I'll be presenting to you guys is that multi-scale analysis of spatially disaggregated data, really trying to capture this distributional content that can be informed these micro. Okay, so now that the motivation is there, what is the general relevant quantity that I'm interested in studying? And so again, we will look to my PhD advisor. He wrote this published paper in 2020, where he said that cities are characterized by fast change across many variables, but the principal quality that you see throughout is one of growth. And both economic growth, demographic growth, and the beauty of it is that we can measure that growth not just in the aggregate, which is what we're typically used to, what typically influences our discourse, but we could also think about that in a multi-scale sense. And somehow, throughout all of this differential growth across space, across scale, some notions of spatial equilibria have still shine through. So how do we get a sense of that? And so really boiling it down to this problem of statistics and of growth. Second, when we then extend this discussion to think about other socioeconomic problems like inequality, we see growth also playing a huge role again. So this is some research, a direct quote from some work by Chetty in 2017, where he argues that we can think about economic mobility, about economic inequality in terms of differential growth. And so now that we kind of get a sense of growth as a word is important, but what does it really even mean? What do I mean? When I talk about it in a mathematical sense, I mean self-replication. So that your dynamics tomorrow are proportional to whatever you're experiencing today. And so this could take many different forms in our world. For example, what economists are really familiar with in terms of production, economic capacity, efficiency, spatial growth, capital expansion, and so on. Growth could mean something about the demographics, about the growth of institutions, about power. Growth often reproduces itself through preferential attachment processes, stickiness, accumulation, and will be transferred intergenerationally through time. And as well, growth is also a very path-dependent process. It's not one that you can understand by just plucking out in the moment. You have to really take a view throughout time to really understand how the status quo of a city, for example, could have some causal relationships with the growth of the. So this is all to say that growth is a very messy, it's a very loaded term. And so for this talk, we're going to be shrinking that view, pulling back a little bit to think about growth as just a process of production, and will be our proxy for that will be incomes, and one of demographic expansion. Our proxy for that will be population. And so then what patterns of growth do we actually observe in Chicago? So going back to our toy diagram from before, each of our census block groups will be represented by the population and the average income. And we're going to be treating that ACS block group as like the finest level of organization that we can analyze. But that's really one of this just a data limitation. It's not a limitation on the analysis method itself. And so when we look at growth data citywide for Chicago by block census block group, we see some deceptively simple results. We see that if we were to bin our growth rate in population, our average incomes, our average log incomes, and the income growth rate by block group, we see bell curves. We see normal distributions. Sometimes they have fat tails, as we see the student T distribution. But this is saying that in the aggregate, when we take this completely agnostic view, things look really like kind of way too simple. But with the important caveat that there's quite a wide range of heterogeneity. That is to say, some block groups are shrinking in population, some are growing, and so on. Now, when we look at that in the spatial context, we start to see something that looks more familiar, but then also one that is quite a bit more complex in that growth is it's spatially distributed, it's concentrated in certain places. It's really nice to be giving this talk in front of the Chicago audience so that you guys know what this actually is showing and the history that goes into this map. But we see within this data range of 2014 to 2019, and we stopped at 2019 because the census, because of the turnover in decade, the census reapportioned census block groups. Also, COVID happened, which makes for a nice contained, or it makes for quite a huge break in dynamics due to whatever that was. So we see a large amount of population growth along the lake, population decline in some south side and west side neighborhoods, with the important note that as we aggregate, so as we take population weighted averages of these growth rates, we see all that richness go away. And that's a pretty intuitive idea, but you lose a lot of that story, that story that we would really like to hold on to. And if we look similarly at relative income growth rates, here they're reported relative to countywide, just so we can get sort of like a rough adjustment for inflation, but also so that we can see where which neighborhoods are going ahead, which are falling behind in terms of incomes. We see a much different picture. We see a relative income salvation along the lake and the northwest side and the southwest side. We see largely income growth. In the far south side, income decline. And by the way, for the rest of the talk, I'll be discussing the Chicago metro area as a whole. A lot of my plots are just in Chicago City proper, just to keep things kind of like visually salient. But in the results I'll show later, we're considering all the other counties in the metro area specific to Illinois. But with the similar issue that as we aggregate, well, some of these stories of local decline in these neighborhoods and incomes particularly get washed away. And so we can view this distributionally, this aggregation process, and the consequences of aggregation through this plot here, where on the x-axis we have the growth rate. Orange is the growth rate in population, purple is growth rate in incomes, and then each rung is a unit of aggregation. So the lowest level is block groups, tracts, community areas, and counties. That's the counts in the data with the population that represents. And this is just to illustrate that as you aggregate, you're losing all that variation. And what you end up when you just look at the aggregate is one of, well, incomes are rising, but population's not growing. But we know, the story is much more complex. And so in light of that, the question then is like, how do we actually keep hold of this local richness? What information do we lose as we aggregate? And so the calculation that I'm going to present to you guys in this talk is one where we do just that. We just record this local relationship between prevailing incomes and population growth. And so say I have a set of block groups that define a tract, and the boundaries of that tract are given by this magenta, the magenta dashed line. And so what we do in this calculation is we observe that in high income census block groups, so these ones with the big money stacks, the population is either gray, which means there's no change, or the population is orange, which means it's growing. Meanwhile, in the low income census block groups where the money stack is small, we see that the populations are purple, which means they're declining. So here we see a relative shift in the income towards higher income block groups, a shift in the population towards higher income block groups, sorry. And we can measure that as a positive covariance between incomes and growth. And to borrow directly from the ecology literature, we would call this positive selection for higher income block groups locally, specific to this track, which is the important part. And so that is to say, when I talk about selection throughout this talk, I mean that there's a covariance between two of our quantities, but this calculation is specifically trait and population change. And so say we had, as we do in a city, a map of CBGs in tracts, well, we can record this locally for every single tract internally. And so for each tract here, we have tract A and B, where tract A is what I just showed before. Population is shifting towards the high income areas, whereas in population B, they're shifting away from higher income areas. Away from higher income areas and towards low income areas. We would measure here positive selection here for tract A, negative selection for tract B. Then we record that selection, we then aggregate, and then we ask a similar question now for the community area that those tracts belong to. Now, how is population shifting among tracts? So for this toy data set, we see that population is moving towards high income areas, away from low income areas. So we record positive selection, and then we aggregate again and get an aggregate growth quantity. So then the question is, well, how do all these terms relate to each other? And this is where the magic of ecology comes in. They have this thing called the price equation, which allows you to decompose an aggregated growth into disaggregate growth across your population, weighed by this term called fitness that really measures a relative change in the population share. So to get that F, we essentially take the population divided by the average population, so that if it's bigger than one, do you have on average more? But anyhow, so we disaggregate or we decompose the growth rate in terms of that, what we call a transmission plus that selection term. And this is an exact relationship. And this allows you to really ask how compositionally your population is changing and how that compositional shift then essentially manifests in your aggregate growth rate. And the beauty of the price equation and equations like the price equation is that this decomposition is recursive. So we can then take the growth rate in this term, decompose it further, and get another covariance as well. And so now to take a step back and ask, well, what does this mean for spatial data analyses? We'll say, we're interested in studying our data across levels of organization, from the individual to the nation. Well, we can decompose that growth in terms of selection effects at each scale independently. And then this allows us to ask questions such as, well, growth at what scale? What factors matter at the scale? Is it migration? Is it differences in investment? And so on. And what is the coherence and selection between scales? And so what I mean by that is like, we'll see this later in the data, but for example, we could see a preference towards high income block groups, a preference towards low income tracts, and so on. So we have this nice statistical independence of scale that lets us, run parallel analyses. And so, like I mentioned, there's several different kinds of equations that behave like the price equation. There's the one that I showed you just now, which is this population weighting. So we're asking, how is population sorting along this trait, where here the trait is incomes. There's another type of price equation that comes from the capital allocation literature, where we can ask, how is this trait spatially redistributing? So for the first part, or for the next part of this talk, we'll focus just on this population sorting along traits. And so before I get into the data, we should talk about what this actually means, because I'm throwing around a lot of words and a lot of math, but this matters. And this, like I mentioned before, this really comes down to what is the quality of your data. So with the ACS data, we have these aggregates that's encoding a lot of the structural context of the data. A previous postdoc here, Laura Fürzik, who works in Sweden now, has access to this really high resolution, individualized data where you can more when you track changes in incomes, it changes in individual income, so you have a bit more resolution there. But what we're trying to extract here is that this compositional shift is really representing some emergent preferences, some preferences in context. With the point that the preferences we measure are scale independent. Like I mentioned before, we can compute a unique selection value for each scale. And so, and just to illustrate this again, I showed here within census block group in tract A, we had positive selection, but at the same time, we could have negative selection at a higher scale of organization. And so this allows us to think about preferences, as a scale. The math is scale independent. The preferences we extract are scale dependent. With the other point too, that our definition of traits can be flexible. Here I'm talking about incomes. I open with an example about infrastructure. We could replace incomes with infrastructure volumes. The data sets exist. So this is quite a flexible methodology here. And like I mentioned before, we're kind of limited though by the level of aggregation. And so if you wanted to really study things like residential mobility, you would need a different kind of data than we had in this analysis. Okay, so that was part one of the talk. And now part two is, well, what does the data actually say? How in the city of Chicago between 2014 and 2019, how does selection empirically depend on place and scale? Are there any questions so far? Yeah.
With the income increase, is that adjusted for inflation?
Not in this work, but the nice thing about this analysis is because it's all locally relative. I haven't shown this, but you roughly get an adjustment for inflation because it's all relative analysis. Yeah. Thank you. Great. Okay. So I'm going to show you a series of maps now where we measure first selection among block groups within tracts and then aggregate them to the community level so we can see what is that local selection looking like in community areas. Aggregating the data, then computing selection across tracts within communities, and then asking regionally within a community what does selection look like. And so for these near north side neighborhoods, we observe that among block groups, we see pretty negative selection. And these selection values are reported, I should say, they're reported relative to the overall growth of the metro area. So when you see 15, that's like 15% of the overall growth we see can be attributed to selection at this scale. or sorry, selection at this scale is 15% as strong as the empirical growth. So what we see,
This is population or income.
this is income, is all. So we see here negative selection in these near north side and northwest side neighborhoods. That's to say, locally, people are preferring lower income block groups. But then we see pretty positive selection among tracts. And so this is an example of competing effects between scales. We see competing preference expression or traces of that to the data. When we look closer towards the loop in the near west and near southwest side, we see more complementing effects. So in the near west side community area, we see pretty strong selection locally, and then also positive selection among tracts. Similarly, along the lake, we have pretty negative selection. In the lower west, the near southwest side, so that includes the lower west side, Bridgeport, McKinley Park, we see competing selection between scales. And then in region 3, which is the areas around Hyde Park, like Kenwood, Englewood, Grand Crossing, we see just a really, between scales, there's not a lot of coherence in the data. That's what we see. Cool. So, yeah.
These results lie quite strong. Are they quite sensitive to the definition of the boundaries themselves?
That's a huge question. Yes, definitely. I'll get to that later. Yeah, but that's a great question. So I'm going to do 3 mini analyses on this data before we wrap this talk. The first will be a spatial concentration analysis, and we'll think about a bit about population scaling. And then we'll see what the price equation, when applied to this data, actually shows us about compositional change in the city. Cool. So what we see is that spatial selection is really highly concentrated. There's about 20% of tracts, 20% of communities that account for about 60% of all the variation we see in the data. And when we look at the distributions of selection we observe, we see that that's represented in these really fat tails at both scales. There's a slight skew in the data to show, that's to say that there could be some local spillovers between units that would track with the spatial concentration that we saw in both income and population growth rates. We see that, so what this table is showing is for every level of organization, what is the absolute value of selection on average and in terms of the standard deviation that we observe. So this is really giving us a sense of like how strong is selection, positive or negative. We're not really worried about it. But we see on average that locally among block groups, it's about 13% as strong as growth overall, and then there's a really steep drop off towards larger levels of organization. And that's to say that sorting is intensely local. And therefore to derive any model of residential selection for a city like Chicago, you would need more complexity as you get to a smaller scale of definition. And this result reflects some results that we had in another paper where we looked more at distributional features of the income data to infer this notion of complexity. I encourage you guys to check it out. This is one of the results from the paper that is saying that as time has gone on, you see complexity as measured by the amount of information required to describe the distribution at local or at smaller scales has been increasing. And so that's to say that like the spatial flavor of the city is becoming more and more locally specialized or locally complex. So now onto the second analysis, which is of scaling. So this concept of scaling comes from the biology literature, has been thrown around a lot in the urban science world. Scaling as a theory is one that says we can use some structural constraints about how people interact with the city to learn about how the city like manages incomes and so on. I'm not interacting with that theory necessarily, just using it as an inspiration to think about, well, as we look at different counties within the metro area, do we see any patterns of how the selection scale with the size of that county? And so if we take like a really agnostic look at that and we say, well, what's the average selection unweighted by population anywhere? We see that in bigger counties, there is more selection. So naively, selection is stronger in larger counties, but then when we factor in the population of individual tracts, and this is selection between, within block groups of tracts, we see that the important point being that we plot on a log plot the population, the selection, the slope gives us some insight on how these two quantities relate. And so the fact that that slope is greater than 1 is to say that there's a superlinear benefit of population to selection. Now, when we factor in the relative population of these units, we see that that slope goes to 1. So now there's just a linear relationship between population and population-weighted tracts selection. But then when we factor in the full population information we have, so that's to say now we're really measuring like a per capita experience of selection, we see that slope collapses to 0. So now that selection is completely independent of population. So this is what this really is just like, I'm not claiming anything general here. This is just descriptive of the data, but it does suggest that potentially selection is something that is a pretty population uniform phenomenon that we would need to look in other data sets to get better insight on. Cool. So now for the last little bit of analysis, what we can do with the price equation is now aggregate all of this selection data to the level of the metro area. The price equation looks like this, where each of these S's is the selection value computed at each level of organization. So we have selection among block groups within tracts within community areas within counties within the metro area, and then aggregated to the metro area. And we see that selection is almost 0. So that's to say, in spite of all this heterogeneity and richness that we saw in these other data sets, in aggregate, there's very little net turnover. We suspect that this could be something fundamental about cities, that there's some conservation in the sense that's a subject of some ongoing work. But this raises a lot of questions. One like that was asked in the back earlier of how do we use this selection as a way to identify meaningful boundaries within the city, boundaries along which like you observe consistent selection. But we could also ask other questions about the generality. How does our measurement of selection track with people's perception of communities and perception of scale within the city? How does selection vary with the morphology of your city? So Chicago is a pretty diverse city in terms of urban form. We have, a Manhattan-esque downtown. We have an LA-esque periphery. But we could ask a similar question for each of those two cities and see what kinds of selection we observe there, as well as the fact that Chicago is a city that's undergoing not necessarily spatial expansion, but infill. We could compare the results from cities like Chicago or New York to cities like Charlotte and Houston, where there is a lot of spatial expansion as well. Cool. So now for the second to last part of the talk, but one that I'm pretty excited about, is this question that can selection contribute to studying and understanding local narratives of change in cities? And this is a question. The question of how to describe urban change is one that we're all familiar with. Is a really complex and complex question. It's one that data-driven techniques really struggle with. And so here's a review paper that was written recently on really understanding studying this question of how can we use data to understand gentrification broadly. And the author points out that there's two main efforts along these lines. One of that is qualitative, really relying on local qualitative contextual information. So to study, say, gentrification in Pilsen, you ought to know what's actually happening there. Whereas the quantitative efforts seem to be pretty vaguely defined, lack a sense of variance in terms of geographic scale. There's also this problem that we only really talk about gentrification as occurring within cities. It's not something that can be generally applied across human developments. But a description or a definition ought to be able to have that flexibility. And so what I see selection as enabling is really by leveraging these local and relative measures of change, we get a scale and place dependent definition for what local changes could look like. And we achieve that through this in-unit demographic measurement of demographic and economic interaction. But really, my goal, what I hope you guys take away from this is that this is a very flexible analysis, can be flexibly defined in terms of boundaries, in terms of scale, in terms of desired trait. Cool. So now let's see this in action. So in this, what I'm going to show you in this slide are 4 regions of the city where we observe relatively similar population, income, and selection results, where that selection is capturing that sub-aggregate interaction between the performers and people. And so for these lakefront community areas near the loop, we see broadly population gain. We see a pretty mixed economic picture, where on the nearer south side communities, there's a decrease in income. On the north side, there's not much. In the loop, there's a bit of an income increase. But what we see in the selection data is that selection is pretty negative on average. And so that is to say that where we see population increase, that's population increase in the lower income block groups and tracts of these neighborhoods. And so that would represent some kind of, and I'm saying these terms really loosely, but like an equity inducing in-migration revitalization of these neighborhoods. Now, if we look to the near west side, near northwest side, we see population growth that's pretty modest, slightly positive, pretty strong relative income growth, but even more positive selection. So that is to say, the people that are moving to these neighborhoods are moving into high income areas, and this would be potentially some evidence of residential sorting, of income concentration. Now, if we look to these south side neighborhoods of East Englewood and Grand Crossing, we see there's population decline, income decline, but when we look under the hood at how they're interacting, we see negative selection, which would suggest that the population decline is mostly relatively higher income people leaving these lower income areas. And so this is an example of flight. And then lastly, into the near southwest side communities, where we see population slight decline, maybe a bit of stagnation, pretty high relative income growth. And as I showed you in those plots before, there's pretty strong selection at both scale that are combining to give us relatively like almost zero selection. And so that really, what we would say is like a complex scale dependent selection process could be evidence of something like gentrification. And so another place of where we're pushing this work forward is really solidifying some of these qualitative insights that we get from the data. Cool. And so that's also, in summary, selection can complement these standard analyses that we can do with income, with population growth, to reveal some of these underlying processes. Okay, so far I've talked a lot about population selection, this sorting along the trait. For the last part of this talk, we'll talk about how incomes themselves are redistributing. And are there any questions before I get to this last slide? Yeah. Yeah, I didn't include it because I picked these communities because they group together really well, and they collectively had like a pretty clear like deliverable picture. It would be really interesting to see what's happening in South Shore with this data as well. I didn't for any other reason besides aesthetics. I didn't. Any other questions? Okay, cool. So here we're really asking how are through growth rates, how are incomes redistributing throughout the city? And so during my PhD, I did a bit of work to show that this measurement is one that should predict changes in inequality pretty well. So this is a regression of income selection among tracts within communities to the change in Gini among tracts and communities. And we see with an R-squared, with a positive slope and an R-squared around 0.5, 0.6, depending on how you slice the data. So that's to say that this measurement is giving us a decent signal on changes in spatial inequality, so inequality between spatial units. And when we measure the selection, and this is measured the selection and then aggregated with the price equation to the level of the city, we see that on average selection is pretty strongly negative among block groups within tracts. And so that's to interpret that loosely through this relationship is to say that selection is causing a decrease in spatial inequality. That's with the caveat that is spatial inequality between block groups. So that is maybe a signal, but not exactly a direct measurement of inequality, experience inequality between individuals. And that's all I have for you guys today. So as a recap, I set up this problem of studying multi-scale change in the city. I identified growth as a pretty decent candidate for understanding that in a mathematically consistent way. And then I showed that despite incomes and population being very well behaved, remember those bell curves in the aggregate, there's a lot of complexity underneath that. And two, we lose all that rich heterogeneity if we just do standard aggregation. However, if we apply these price-like equations, we can not just retrieve some of that heterogeneity and record it, but we can also get some insights on some of the local selection processes. We showed that this population sorting is really highly local, spatially correlated and concentrated. And they suggest that there's some reduction of spatial inequality. And so this work was enabled through my funders at Oxford. I had a lot of help from the former Mensueto postdoc Lara in getting closer to thinking as a sociologist, as a non-sociologist myself. And as well as help from Luis and Elias, who's a wonderful postback as well. So that's all I have. Thank you, guys. And then the most up-to-date paper is this QR code here. And then the paper on the decoding the city, this information theory stuff, you can get that QR code there. And I'm happy to take any questions if you guys have any.
Yeah, you talked about setting up multi-scale change in the city, and but it seems like you focused mostly on like a mathematical model, right? Okay, so I don't know, like the mind state of someone who would be tracking heterogeneity in blocks, kind of like, I don't know, it makes me want to ask you, what are these frontiers of change other than income?
Yeah. So these are things that I kind of alluded to throughout the talk, but didn't make like super explicit. I use income here as an example of how we can apply the framework. But the framework itself, it's not a model. It's just it's another way to look at the data, essentially. A way that as we aggregate this data to the level of the city, which is when policymakers maybe at the national level think about Chicago, they think about it in terms of these aggregates. So the challenge is when we go to these policymakers and we say Chicago's stagnating, well, that's not true at all. But how do we summarize that change in a way that can capture all this complexity? And so here I presented a way to do that with incomes, but the same math can be applied for infrastructure. It could also be applied to demographic change, which I haven't showed, but I plan to do in the future. So
you have the mind state of a politician.
I wouldn't say I have the mindset of the politician, but in terms of communicating the complexities of the data, it's important to think, if somebody's looking at these results, they have 5 seconds to get a summary. How can I communicate the complexity of the problem? So that's the perspective we're really trying to help guide the inquiry here. When we try to develop summaries of the city, what are ways we can enhance those summaries so they're a bit more revealing? Yep.
This was great. This was exciting. I will not claim that I understood every part of it, but a lot of food for thought. I love the general sort of questioning of the spatial aggregation convention, whatnot. The census, it also aggregates temporally, though, or it gives us these sort of point in time snapshots. And so I'm just wondering, Luis's quote about why do we think of these as equilibria? Well, the notion of change or the notion of equilibrium, it has a temporal sense. Change only means something time A compared to time B. So I guess my question is so this particular work, this was all 2014 compared to 2019, is that right? So why is 5 years the period of time at which we would expect this kind of change? Why is that the relevant kind of time scale at which to look at this? Why not 1 year? Why not 10 years? What?
Yeah.
So what, like, so yeah, I guess, you know, think about your project a different way.
Yeah.
What does looking at it in a 5-year time scale obscure or
Mhm.
reveal that looking at it at a different time scale wouldn't?
Yeah, that's a great question. So I think the intuition that we use is that there's a trade-off in time scale. If you go too short of a time scale, you're capturing a lot of noise. So maybe there was like a good year for the housing market and I don't know, a ton of people, you know, you get what I mean. Like the shorter in time scale you go, the more likely you are to capture that noise. But then if you go in the other direction towards a really long time scale, you're more likely to capture multiple trends. Exactly. I like that. Yeah. So there's this art of like picking the right time scale. I don't claim to have picked the right time scale for this analysis. We could start to ask that question. And as we increase the scale of our analysis, what patterns of selections we observe? Do we start to pick up artifacts of that noise or artifacts of that aggregate change? I hoped in picking this range that we could capture at least some of what we would like to think of as preferences. Yeah, I mean, like you said, it's a bit of an art for now, not quite a nailed down science.
Yeah, I mean, to come back to like thinking like a politician, you know, you hear it brought up a lot that like the 4-year electoral cycle is actually not well kind of matched to certain things that politicians actually are tasked with doing, like developing infrastructure, for example. And so I think, yeah, it's an important question.
Yeah. No, that timescale mismatch is a huge problem. Anybody who's worked in policy knows that a lot of the things we set out to do cannot be done in 4 years. The timescale of urban change is often in decades. So yeah, there's a lot of interesting questions to try to wrangle here. Are there any other questions? Yeah.
What country was your data from? Was it the Swedish census?
Well, no, this was all Chicago
Oh,
census data. We are working to also do this analysis on Swedish data as well. Yeah. Yep.
We're doing a project here in Woodlawn called Woodlawn Central.
Mhm.
We're building an economic model to show the benefit of the project for sales tax, parking tax, property tax, hotel tax, amusement tax, etc.
Yep.
But we also have all of this data about our exact square feet, you know, and we're going to track point of sale information, and we're going to compare our projections to what, you know, actually happens as the project gets built out. What I'm wondering is how could this methodology, could we implement now to show the history of the local neighborhood? Because there used to be a business district there. There used to be all of these things.
Yeah.
We would love to show how we're regenerating everything back. So could you speak to how this tool set could apply to that?
Yeah, so there's two things there. One is taking that historical perspective, one is taking the modeling towards the future.
Yep.
I think doing a historical analysis, this would help you uncover whether, and you said this was Woodlawn?
Yeah.
Okay, so whether like divestment was one of like just broad divestment, or were there like these, you know, potentially preference-driven patterns of, well, maybe that block group or that tract fell out of fashion, but you know, generalizing that measurement a little bit through setting up, you know, organizing the data, computing these selection effects. We generally summarize that as like compositional changes.
Yep.
And so I think the challenge is in really articulating what does a compositional change mean for infrastructure, for population, and for income changes in Woodlawn. So I think once you define those terms, then you can start to ask, or you'll get some clarity on what a selection analysis could reveal.
Interest. Because also we want to do growth without displacement.
Yeah, and we should talk more about this later.
Yeah, sounds great.
And then I have to go soon, but you had a question?
Yeah, I just wanted to clarify one thing.
Yeah.
When you talk about income, you're talking about per capita or household?
So that was per capita average income for a block group.
That's what I thought.
Yeah.
And I guess then like it makes me think like you were talking about demographics also.
Mhm.
I think like do you want to clearly there's like, you know, we talk about population, there's like families and households, you know, minors. Are you taking like the strategy to trace demographics to like account for
Yeah,
Like,
yeah.
like some people, like minors can't choose necessarily.
So I haven't, however, using this analysis, which I really didn't talk about today, you can ask, well, how does what are the compositional changes in this particular demographic? And that could be age, it could be gender, it could be race. So that's work to be done, sure.
And then what about household unit? Is that kind of?
You could also use households as well, yeah.